Hello folks, and welcome to what promises to probably be a super boring video, I'm afraid. Yeah, it's that time again. So what we're going to be doing today is giving you an update on our Model 3 PCS hacking. It has been a while. Just to quickly recap, our Model 3 PCS, the one that we're going to be working with here today, was donated to me back in 2019 by a supporter on Patreon. It is a US single phase version. We did quite a bit of work with it here on the bench, to the point we were able to get it to kind of start to wake up a little bit. I got the DC to DC converter to wake up and managed to see it doing some pretty strange stuff there. So sometime after that, we got it installed in the Grey Goose, which is our E46 Touring conversion project, and finally, over the last few weeks, got it wired up, pulled the PCS controller out of mothballs because I had built a prototype, and we will go into some detail on that and show you how the hardware interface side of things works to the PCS. We have some success here in the last week or so. Got the DC to DC converter to wake up and start basically charging the 12 volt battery and powering the 12 volt systems in the car from the high voltage system. And fairly recently we managed to wake up the charger side for the first time and was able to push it up to about 6.8 kilowatts. It is rated to go to 10. That would need in or about 50 amps from our 230 volt single phase supply. Unfortunately, the most I can pull from my Tesla EV SE at the minute is 32 amps on single phase. Fortunately, here in this country, we get pretty crap power. We get a 60 amp 230 volt single phase supply only. We don't get three phase, we don't get any more power, at least in a domestic setting. So I'll have to rig up a temporary 50 amp supply to push this thing all the way up to 10 kilowatts. But we can do that, and probably will at some stage. But 32 amps is very respectable. It gives me, 6.6, 6.8 kilowatts. And I can draw that from on-street AC charging points also. So that's pretty darn good. And I get the DC to DC converter that can put out about 220 amps at, whatever, 14.5 volts. So it'll definitely handle all of the 12 volt needs that our vehicle has. So the software has been a bit of a struggle, if I'm honest. We've been kind of going back and forth a lot on it. But we do have what I would consider an alpha version working here. So that's what we're going to be messing about with here today. I'm not going to be able to show you the software just at this time. The reason for that is that there is quite a bit. I had to draw quite a bit on the work that Matt and myself did on the Model 3 charging port. And there's quite a lot of Matt's findings in there that we've needed, or that I've needed to use. So until I kind of talk to Matt and we figure out what kind of a direction that we're going to take with that, I'm not going to be making the software open source at this point. But what I can show you and will go into some excruciating detail on is the hardware side of things, and can show you the basics of the control that way, because there's quite a few catches in there So we'll go through that with you. And I can probably talk in some general terms about what some of the CAN messages, some of the little catches in there that would and did fool me. Okay. Right now, here, what I have is I have a 15-meter extension lead going out to the car because it is a horrible day out there. We have the PCS controller plugged in. I've got my EV-SE plugged into the car also. And we're kind of in idle state at the minute here, as you'll hopefully be able to see on the little menu. There's still a few bugs in this, which I'll get into in a minute. But we should be able to wake up the car, wake up the PCS, fire off the DC to DC converter, and push the charger up to about 6.8 kilowatts. So that's what we're going to do in this little segment today. All right, so there's nothing to do but to do it. So let's have a look here. So, all right. You're going to get to see the back of my head now while I'm looking at the computer screen here, but you'll be able to see the screen here as well, so that's the important bit. All right, so just turn the scroll off here for a sec. So if we look here, we've just got our charger parameters here. So we have AC power, AC current limit, current AC current, AC voltage, and DC voltage. Now the first thing is that the message that contains the DC voltage does not come up until we enable the charger side. Next up is our DC to DC converter parameters. We've got the voltage, which I haven't decoded properly. So you'll see this change, but it won't make a whole lot of sense. Good news is the DC to DC current works perfectly. So next down then, we have our VCU mode, and that's currently off. So we have a very simple little CAN protocol implemented now in the Zombieverter VCU that allows external devices to call for high voltage on and high voltage off. Mainly the charger. So a charger controller can send a CAN message to the VCU and ask it to turn on and turn off the high voltage. And we send a little bit of very basic data out that way. And I can obviously talk about that because the Zombieverter is a completely open source project. So at the minute, we're in an off state, and I've just rigged up some very simple commands here. If we press C, it turns on and off the AC. F turns on and off the DC to DC converter stage. G turns on and off the charger. E turns on and off the PCS enable, and M toggles between US and EU model. And P followed by a number sets our charge power in watts. And then I have a few little flags here that just tell me basically what I have turned on and what I have turned off. Now I guess the one thing in there that does warrant a little bit of explanation is toggling between a US and an EU model. What that's doing within the program is it's changing some of the CAN message content. It's not a lot, but it does need to change. And it's also changing the length of, I think, 2 messages. So the messages contain the very same data between the US and the EU model, but if you transmit, I guess, what I'm calling the US message length, which I think is 2 bytes, to the EU one, it throws a fit. And if you send the EU message length with the same data to the US one, which is I think 5 bytes, it throws a fit too. I think there's 2 messages that I have to change the length of, but not their data content. And I have 1 message that I have to change the data content in, but not its length. Now, one thing to be very cautious of with particularly Model 3 parts is that a lot of these differences may not necessarily be down to the origin of the part. So what I'm calling a US and EU PCS. So for example, the US version takes all of its power on single phase, so up to 50 amps single phase. And the EU one splits that over 3 phases and takes 16 amps per phase. So 3 times 16, 48. So would they accept the same CAN messages if they had the same firmware versions on there? Possibly, I don't know. But it's fairly safe to say that due to the fact that there was at least a year between them coming out of their parent vehicle and they're coming from different continents, that there would be different firmware on there. If you are interested in a lot of the differences between the internals, I'd recommend having a look at some of my earlier videos on the PCS where I've got them, opened up on the bench and that kind of thing. So, all right, let's get back on here and start waking stuff up. So I'm going to put the scroll back on here. So, another thing about it is that very like the Gen 2 and the Gen 3 chargers from the Model S, it is particular about the order in which things happen, at least so far as I can tell. For example, if I bring up the PCS, but I don't enable the functions that I want within a certain time, it just goes blah, and then I have to shut it down and wake it back up again. And that's probably again because I'm not handling the CAN 100% correctly. So if we press E and hit enter, what you're going to see is you're going to see the VCU mode will go to pre-charge, then it'll go to charge. So that'll be the VCU confirming to us that we've brought up the high voltage. And what I'm going to do then pretty quickly is I'm going to type FGC. So that's going to bring up the DC-DC, the charger section, and turn the AC on. We just kick the pilot signal on for the EVSE. So I'm going to do this pretty quickly. So let's go for E, and we should see pre-charge and charge, FGC, enter. All right, so straight away, what you're going to see is that our DC to DC voltage did move a little bit, but again, I don't think that's correct. We do have a read of current here. What am I doing with my thumb? I need to be showing you the mouse. So this is the current coming out of the DC to DC converter going into our 12 volt systems. So we've also seen that we have AC voltage being measured, and we have DC voltage being measured. Now, if I enter a power command like P1500, enter, that might work. Because I'm on camera, it probably won't. Right, yeah, here we go. Here we go. So, okay, so right now, our charger section, we've told it to put 1.5 kilowatts basically into our high voltage system. And you'll see the high voltage will start to rise there. Now that's 1.5 kilowatts AC. Again, like the Model S chargers and whatever other models there are, he's starting to fill up the friggin' alphabet with the things now. Let's call them the previous versions. They limit and are commanded by the AC side. They don't care about the DC. They just translate that. So that 1.5 kilowatts will get translated in minus the losses in the power conversion to whatever that equates to at the measured DC voltage that we have here. So let's take it up a notch, as they say, and let's go for 3 kilowatts. So P3, 1, 2, 3, enter. And we should see that come up, or at least we would if I had actually put the cursor in the box here. So P3, 1, 2, 3, enter. Yeah, okay, there we go. All right, so we're up to 3 kilowatts now on the AC side, and you see we've come up to about 13 amps there on the AC side. So let's go up to let's go up to 5 kilowatts. Enter. Now we're starting to warm things up. So that's 5 kilowatts. You see the AC current, and obviously the DC voltage is increasing now. We're basically pushing more DC current into the high voltage battery. At least I think it is. I hope it is. The other thing about these, the other thing to be careful with, yeah, they are coming up. The high voltage DC voltage and the DC to DC 12 volt system voltage are in multiplex messages, and I'm not 100% sure that I'm hitting the right part of the multiplex definitely for the 12 volt voltage. I'm probably not. I think for the high voltage, I think I am doing pretty good on that. So okay, but you'll see it's a bit slow because I think it's like there's 15 or 16 parts to the multiplex, and it's only a 100 millisecond message, so it means that by the time it comes around, it's 1.5 seconds per update. So that's why you'll see the DC voltage here, the high voltage use the cursor, take a little bit of time to update. Okay, so let's go up to let's go to 6.5 kilowatts. 6500. Enter. Here we go. Are we going? Are we going up? Yes, we are. Oh yeah, I can hear the cable starting to hum. Okay, so that's about 30 amps on the AC side, and obviously our AC voltage is is going down a bit, so that's not good because now it's going to want to draw more current to compensate for that. It's kind of the middle of the day here, so I guess people in the area are using things, and there's it pulls down the local voltage or whatever the substation is. That's about as high as I want to go at the minute, because I do have a 32 amp breaker on this thing, yeah, so this is our basic control, or ability to command the PCS at the minute. I do have the command for the DC to DC 12 volt voltage set point. I do know where that is. I have it just set to 14 volts at the minute. So need to figure out that part. Or not figure out that part, just put that in there so I can actually set it. That's only an Arduino menu type thing. What else is there on this part? That's kind of what that's kind of what we have here at the minute. I'm actually very happy with this. I didn't think that I was gonna get it. At times it was it was pretty crazy, but yeah, it's coming up there nicely now. So what I've got to do next is put in some kind of a DC set point. So you want to charge to this voltage using a maximum of this power, which we will want to derive from both the proximity for the cable limit and the pilot signal when we plug the car in. We'll want to charge to this voltage, decrease to this current and then shut down. And obviously accept an external shutdown command, be it from the VCU or a BMS or whatever else. So that's probably, because at the minute, this will just rock on. I don't know what the maximum voltage is for the PCS, but this thing will just pretty much keep on charging, I would suspect, because I've not seen anything in the can so far that would say that there is a way to tell the PCS to go to this voltage, because the high voltage controller is in charge of the PCS. Basically, when we're sending this power command, that power command originates from, what message am I sending that from? Oh God, I forget. I think it's the BMS. I think that's the origination of the power. Yes. It's not, no, yeah, the BMS originates the charger current, not the charger current, the charger power set point. The charge port message tells it what the maximum is. You see there we got maximum AC limit 32 amps. I'm just using a static value in there because I know that's what the EVSE that I have here at the house can do. But when we go to the next stage here, obviously we need to read that. So that is, it's I should also bring up some of the temperatures here, because it's got a bunch of temperatures, as about, I think I'm going to say 4 or 5 temperatures. So there's temperatures for the various phases, temperatures for the DC-DC. There's even an ambient temperature sensor that's just inside the casing of the thing. I think I did manage to break one of the sensors because it's reading garbage, whereas the one on the EU PCS that I have in the house is reading fine. So I did manage to break something. Okay, that's where we are at. I'm not going to put too much energy into the car at the minute here, because what I want to do is work on the software for a bit, to the point that I can tell it, to go to a particular voltage, and just work the bugs out of my ridiculous coding. And then once Matt and myself talk it out and we have a plan, we're going to have some hardware for you folks that will be 100% open source, and we'll have some kind of a software solution for you. If it goes open source, it'll probably be my stupid, as I call it, DDC dumb Damien code. That'll be, so what you see here. And I can't, I can't tell my right shift from my left shift. So, yeah. So we'll be doing that. That's one choice. Or the other choice is we'll have some adults involved in that. And it'll probably go something like the way Johannes does the new software for the Gen 2 and the Gen 3 charger. So that's where we're at. I did think about incorporating it into the Zombieverter, because there's some new hardware coming down the path for that, as you're aware. But I'm actually not. I've kind of pulled back from that idea, Because if I'm going to support the PCS, then I need to support it. You know, there's so many different chargers and things. So I think the best way is to just have a API, I guess, that the OpenInverter will transmit certain data that a charger might need, and will accept, commands and requests from an external charger controller. So, Gen 2, Gen 3, PCS, an Ampere charger. There's probably lots more charger hardware stuff coming down the road, as well as drivetrains and all that. Folks, I don't know whether I'm going to go ahead and show you some of the hardware, or I might do that in a different video. You're probably fairly tired of this one. We've been recording here for 25 minutes so far. So what I might do is wrap this one up here, and we might give you the hardware side of things then in another episode. Keep it a little bit bite-sized. How's my... Yeah, we're not exploded yet anyway. But I think definitely my 14 volts or my 12 volt system thing, I think I'm left, am I right shifting too much? I don't know, I can't tell. All right, okay. I'll stop here. Thank you very much for watching. As always, don't forget to dislike, do not share, unsubscribe if you've made the mistake of subscribing to this stupid channel. Check the links in the description for Patreon and PayPal in case you wish to keep me in the life to which I've become accustomed. Yeah, no, silly. Also links in there to GitHub, OpenInverter forum, JLC PCB, PCBWay, all the, anything that I can find that I can put in there that might be useful to folks. So, this is it for today. We'll be back to you soon with a PCS hardware. So we'll call this kind of, I don't know, PCS demo, whatever you want to call it. It's too cold for me to go outside, so I'm not going to be doing that. We'll do that someday, the sun's shining. All right. I've waffled on more than enough, haven't I? Yes, I have. Okay. All right, folks. Until next time. Happy right bit shifting. Or is it left shifting? Left is multiplication, or is it left is division, or